So in this work entitled One-Shot Learning of Scene Locations via Feature Trajectory Transfer, we investigate the problem of one-shot learning, that is, given visual categories and you only observe one image of each visual category, you want to train a classifier to decide to which category a novel image belongs to. This has been done multiple times in the literature, however mostly in an object-centric setting. In this work we specifically focus on scene recognition as our target application. So since one-shot recognition is typically addressed in a transfer learning setup, we looked at different sources of variability in scene recognition that we could potentially use for knowledge transfer, and found that the predominant source of variability is variability in the scene configuration, meaning, for instance, different types of beaches or mountains. The second type of variability that we identified and that we specifically look at in this work is variability in the transient states of scenes, meaning variability in the attributes sunny or dirty or foggy, for instance, and how we can leverage this for one-shot learning. So in the first experiment we actually looked at how limited variability in the transient state affects recognition, and here on a very simple problem of assigning webcam images to the correct webcam. For this purpose we use the transient attributes database, where every image is annotated by the strengths of 40 different transient attributes. And using places CNN activations as features, we show that recognition accuracy actually drops by almost 20 percentage points when comparing cross-validation to a setup where the training data is limited with respect to the strength of certain transient attributes. So the second question we looked at was how much variability we actually observe in current state-of-the-art benchmark datasets, for instance places or sun, and actually found that the variability with respect to the transient states is actually very low, and more details can be found on the poster. Third, we propose an approach called feature trajectory transfer that should allow to mitigate this limited variability problem, at least to some extent. The idea is to learn how feature representations change as a function of the transient attribute strength, then transfer these models to new previously unseen data, and finally synthesize additional representations given certain transient attribute strengths, and then train a discriminant classifier on top of that. So our results on one-shot recognition of scene locations, or webcams as you've seen before, shows that if you add existing approaches to one-shot learning, you can actually improve the results over training with single instances alone, indicated by capital A here, and the other approaches by capital ML. But in any case, if we add features that we synthesized using feature trajectory transfer, we can actually obtain gains ranging from 1 to almost 4 percentage points. And I'm more than happy to answer any questions at our poster in the next poster session. Thank you.